In this video, we will be talking about polar coordinates. So here is all what you need to know for polar coordinates. So as you can see, I laid out the stuff that you need to know, and these equations will help you in the problems I will give you. Okay, let's start off with this question. So it says plot the point whose polar coordinates are given. Find the Cartesian coordinates of the point. So here we're given polar coordinates, right? And we gotta somehow convert them into Cartesian coordinates. So let's start off with step one, and we're gonna do the problem A first. So step one, we got our Cartesian coordinates. We got our polar coordinates, and we gotta use this equation from the beginning I showed you. So this is the polar coordinates. It's r, and there's the theta. If you guys don't know what that means, it's basically like the radius and the theta. So polar coordinates, they're basically the radius and the theta. Think of it as like polar. This is the polar coordinates, x and y coordinates, but in reality, this is their own type of version. So the r is going to be equal to 1, and the theta is going to be equal to 7 pi over 4. And how we're going to find the Cartesian coordinates? So we can do the for the theta, we can do this simple trick. When we trying to find it, we have to find the degrees. So we always have to, when we find the degrees, we can multiply by 180 over pi. This will cancel out the pi. And when we do this, 7 times 180 divided by 4, this will be 315. And that's how you get the degrees. And now we're going to get this equation, x equals to r cosine theta, because we have our radius for 1, and we got a cosine 7 pi over 4. And we can do this. 7 pi over 4 cosine is going to be just square root of 2 over 2. So this will be x equals square root of 2 over 2. And we have to do that for the y as well. So y will be equal to r sine theta. And this is from the equation from the beginning I showed you. So r is still 1, sine is 7 pi over 4. And that's going to be equal to negative square root of 2 over 2. So this is our Cartesian coordinates. So our Cartesian coordinates for the first one is square root of 2 over 2, negative square root of 2 over 2. Let's look at the problem B. So we are basically repeating the same thing we did for problem A. So now we gotta, just do the polar coordinates. So r is equal to negative 3 here, and theta is equal to pi over 6. We gotta do the little method to find the degrees. So pi over 6 times 1 over 80 times 180 over pi. Cancel out the pi. 180 over 6 is equal to 30 degrees. Now we're gonna plug in our x and y functions from the equation table from the beginning. Now we gotta basically plug in chug, so this will be negative 3 cosine pi over 6, and this will be negative 3 sine pi over 6. And now we gotta do simple math, so we can use this triangle. I like to do this. So cosine is going to be cosine pi over 6, so pi over 6 is going to be 30, 60, 90. So 30 is 1, 60 is square root of 3, and the hypotenuse is 2. So the cosine is going to be adjacent over hypotenuse. So this will be equal to, so cosine of this will be equal to square root of 3 over 2. And we got a times by negative 3. This will lead us to negative 3 square root of 3 over 2. So we got 1 down. Now we got to do the y. Now we have to do the y. So the y is going to be equal to sine of pi. Let's see, our sine of pi, we got 30, 60, 90s. And our sine of pi is going to be opposite over adjacent. So the sine of pi over 6 is going to be 1 over 2 times negative 3. It's going to be negative 3 over 2. And that is our y Cartesian coordinates. So our Cartesian coordinates for problem B is going to be negative 3 square root of 3 over 2 and negative 3 over 2. So basically, how we're going to plot this, right? So we don't have to plot the Cartesian coordinates, we have to plot the polar coordinates. So in this situation, we could plot A. So whenever you see this, right, they're going to give you, when you have to plot it, they're going to give you a graph something like this. So this, when there's like a circle around like the y and x axis, right? The first circle is going to be 1. The second circle is going to be 2. The third circle is going to be 3, and so on and so on. So the first so we got 1. Let's plug A. So 1, 7 pi over 4. And we know that 7 pi over 4 is located around here next to the end right here. So, but 1, we're going to do, it's located, let's say it's located here, right? But when we have to plug in the 1, right? It's going to be located over here because this equals to 1. And if it's like 2, this is going to be 2, this is going to be 3. And let's say if the R is 2, right? Then we're going to plug it here. Then we're going to plot it here. If the R is 3, we're going to plot it here. If the R is 4, we're going to plot it here, and so on, and etc. So this is plot A. And now let's do plot B. So the first, the radius is negative, so we know it's over here in the second quadrant. So pi over 6, it's going to be pi over 6 is usually in the first quadrant, but in this situation we got negative, so we're gonna be going over here. So wherever you see pi over 6, this is gonna be pi over 6. So this line, so let's see, 1, 2, 3 is gonna be equal to here. This is going to be plot B, and that's how you plot the polar coordinates. All right, so let's take a look. It says graph the set of points whose polar coordinates satisfy the equations and inequalities in this problem. So here we got pi over 4 to 3 pi over 4 from the radius 0 to 1. And for problem B, we got negative pi over 2 to pi over 2. And the radius from 1 to 2. And basically, we're going to have to plot this. So you basically got to look at this, right? Remember, the R is 0, it's going from 0 to 1. So it's going from the center, right? From 0 to like 1. So we're only gonna fill up this space. We're not even gonna touch this, guys. We're not gonna touch this for the first problem, right? So it's going from pi over 4 to 3 pi over 4. So we know that pi over 4 is going to be, we know that pi over 4 is like going to be like this, right? Because pi over 4, this is pi over 4, right? As we know from the unit circle. So pi over 4, and we're going to 3 pi over 4, and that is going to be still going to be from, that's going to be over here. So this is 3 pi over 4. So basically, we're going to go from here to here. So basically, let me just show you. So we're going from here to here. We're basically just shading this in. And that's all you need to do, guys. We're just going to shade this in. And that's pretty much it. And here we have, for part B, we're going from negative pi over 2 to pi over 2. And the radius is going to be from 1 to 2. So in this situation, we're not gonna use this. We're gonna use this part because this is 1, this is 2. It's going from 1 to 2. The radius is going from 1 to 2. So now we gotta find negative pi. Our negative pi is going to be here, and our pi over 2 is going to be here. So it's gonna go. Let's say it's gonna go from negative pi to pi over 2. So we're going to have to circle the whole thing because this is going to be negative pi because we're doing negative pi to pi over 2 and we don't know if it's going to stop in, let's say, negative 3 pi over 2 or it's going to stop at negative pi over 2. So we're going to have to circle the whole thing. And for those of you who don't know, this little spot is negative pi over 2, and when you're going from negative pi over 2 to pi over 2, this is going to be pi over 2. But in the negative version, this is going to be negative pi, and this is going to be negative 3 pi over 2. So we don't really know where pi over 2 is, but we know that pi over 2, if it's going the clockwise version or the counterclockwise version, is going to be from here. So in this situation, we're going to circle in the whole thing from 1 to 2, from the radius from 1 to 2. So basically, that's how you do it. And I hope you understand what I just did. I can make another video about this. So leave some comments down below and thank you for watching.